Okay, here we determine the value of c such that the graph of f of x as a point of inflection at 2 comma f of 2. I have written the point of inflection shortly as p dot o dot I. So let's understand the points of inflection. So these are the points when the graph of f of x changes its concavity. That is, if it changes from concave up to concave down, the point where it changes, we usually call it as a point of inflection. Also, if it changes from concave down to concave up, we also say that at the point where it changes its concavity, it is a point of inflection. So at the point of inflection, the second derivative of the function equals 0. So using this condition, and we know that it has a point of inflection at x equals 2, we are going to determine the value of c. So let's find the second derivative of the function. First, let me find the first derivative by differentiating both sides of the f of x. So I write f prime of x, and this equals c times of derivative of x square is 2x. This is using the power rule, minus I put this 4, and then derivative of x raised to the power of minus 2 is I put this power minus 2, and then raise x to the power of minus 2 minus 1, and this equals minus 3. So it is x raised to the power of negative 3. Let's simplify this. So we have f prime of x, this equals c times 2. These two are constant, so it is 2cx, and negative 4 times negative 2, these two are constant, which is positive 8 times of x raised to the power of minus 3. Since we need to set up this equation, we'll find its derivative. That is, we'll find the second derivative of f of x. So I write f double prime of x, and this equals, we should find the derivative of both terms. The derivative of 2cx is 2c is a constant, and the derivative of x is 1. So I put 2c times 1 plus 8 times of derivative of x raised to the power of minus 3. If we apply the power rule, we put the negative 3 in front and raise x to the power of negative 3, negative 1 equals negative 4. So I put negative 4 here. Now let me simplify this. So we have f double prime of x, which is the second derivative of f of x, and this equals to c. We have 8 times negative 3 is negative 24, x raised to the power of negative 4. And I can now rewrite this x raised to the power of negative 4 as 1 over x raised to the power of positive 4. So therefore, this equals 2c minus 24 times 1 over x raised to the power of positive 4. And since we have to set this f double prime of x equals 0, let's do that. So I'm going to substitute f double prime of x equals 0. So we have this equation 0 equals, this is 2c minus, I write this as 24 over x raised to the power of positive 4. So I'm going to add this on both sides, that is this quantity 24 over x raised to the power of 4. So I will have 24 over x raised to the power of 4, and this equals 2c. Now divide both sides by 2 so that we get c on the right side. And when we do that, this 24 when divided by 2, we get 12. And this is over x raised to the power of 4 equals c. Let's do the cross multiplication. So we get c times of x raised to the power of 4 equals 12, or c equals 12 over x raised to the power of 4. Now, since it is given that the point of inflection of this function is at 2 comma f of 2, we plug in x equal to 2 into the point of inflection or into the expression for c. So therefore, we get the value of c, and this equals 12 over 2 power 4. Replace x by 2. So this gives c equals 12 over 16. Otherwise, we reduce this to simple fraction. That is 12 is 3 times of 4, and 16 is 4 times of 4. So these two 4 gets cancelled, and the simplified form is 3 over 4, that is 3 fourths. So therefore we found the value of C equals 3 fourths, and so answer choice B is correct.